Have you heard of a framework called Hardhat? It's a new framework for smart contract that is getting super popular. One of its key features is a great debugging experience thanks to console log statements that you can use in your smart contract, like in JavaScript. This video is a tutorial to help you get started with Hardhat. I will cover project setup, testing, deployment, and front-end integration. This is not for complete beginners. Before you learn Hardhat, I recommend to first learn Truffle. I have another video on this framework if you need it. If you don't know me, I'm Julian, and on my channel Eat the Blocks, I teach blockchain development. We are going to create our first project. Before, you need to make sure that you have Node.js version 12 or above installed. And after, we're going to start an npm project with npm init. Then we're going to install Hardhat as a development dependency. Okay, after we are going to create our Hardhat project with a Hardhat utility. So for that, we're going to use npx. So npx is something that comes installed with Node.js. It allows you to easily execute executable that are installed locally just for your project. And so here we're going to choose create an empty Hardhat config. Okay, so let's see what we have. So here it has created our configuration file for our Hardhat project. So every time you run a command with Hardhat, you are actually running a task. So you can define task yourself, but there are also a couple of default. So if you want to see all the tasks available, you can do npx Hardhat. And here you can see the different tasks. Hardhat also comes with an ecosystem of plugins that you can install in order to extend its functionalities. So we are going to install a couple of plugins. So let's do this. Install for the development dependencies Hardhat ethers. So this allows you to use the ethers library in Hardhat. Ethers is a JavaScript library that allows you to interact with the Ethereum blockchain. And you also need to install ethers itself. Then we're going to install another plugin, Nomic Labs Hardhat Waffle. So Waffle is a package to test smart contract. It's not specific to Hardhat, so that's why we have to install a plugin and we have to install the library as well, Ethereum Waffle. And we're also going to install Chai, which is a testing library. It's not specific to blockchain. It's used for many JavaScript projects. We're going to launch the install process. And next, we need to modify the configuration file to install our plugin. So we open Hardhat config.js and we are going to require Nomic Labs Hardhat Waffles. That's a testing library. And for ethers, we don't need to require it because this is already required by Hardhat Waffle. And we're going to use 3DT 0.8. So here we're going to change this. Okay, that's it for the installation process. Next, we're going to create a smart contract and compile it. So let's exit this file and we're going to create a new directory contracts. So we're going to create a token smart contract inside token.sol. Okay, so let's open this. So here we're going to do some solidity. So let's use 3DT 0.8. And here we define a token contract and you're going to define some variables. So first, the name of the token, my Hardhat token. Then we're going to define the symbol, MBT, my Hardhat token. Okay. Then the total supply will be 1 million, 1, 2, 3, 1, 2, 3. Then we're going to define an owner. Then a mapping for the balances. So it's gonna map address to integer. Okay, then we define a constructor where we're gonna initialize two variables. So first the balance of the address that deploy the smart contract. So we're gonna give it to all the supply, and then we're also going to make it the owner. Okay, and after we're gonna have a function to transfer token. So address of the recipient, how many tokens are transferred. We make this external, and we're going to require that the balances of the sender, the balance of the sender is enough for the amount to be done. Here our message is not enough tokens. And after we're going to update the balances mapping. So here we remove the amount, and for the recipient we're going to increment the amount. Okay, and next we're going to have a function to give us the balance of a specific address. So we pass the address here. This is a view function. It's going to return an integer, and then we return the balance. Balance is a count. Okay, so now in another terminal at the root of my project, I'm going to run the compilation task. So npx hardhat compile. So first it downloads the Solidity compiler, then it does the compilation. It finished the compilation successfully. And if you check your directory, here you can see that we have two new folders, cache and artifacts. So the result of the compilation are inside the artifacts directory. Okay, so next we are going to write a couple of tests for our smart contract. So let's exit code editor, and we are going to create a new directory test, and inside we're going to create a new file, token.js. That's where we'll put our test. Okay, so let's open this file. And so first we are going to import the expect object from Chai. So Chai is a library for testing in JavaScript, and we're going to wrap our test with a describe block token contract. So first we give it a name, and then we give it a callback function. So if you've already written test in JavaScript, this syntax probably feel familiar. Then we're going to define a couple of variables. So you're going to understand just after why we have two token variable here. Then a variable for addresses, so owner, address 1, address 2. Okay, and after we're going to define a before each block. So this is going to be run before each test, and it's going to receive an async callback. First we get what's called a contract factory, so that will allow us to deploy the token smart contract. Here we use the ethers object, which is automatically injected in the test file by the Hardhat framework. And there is a function called get contract factory. So this is added by the Hardhat ethers plugin. If you just use the ethers library standalone, you will not have this function. And we give it the name of our smart contract, token. And after we're going to deploy our smart contract with the deploy method like this. And finally, we're going to initialize our addresses. So owner, address 1, address 2, and for the rest, we don't care. And here we're going to use a method of ethers called getSigner. So that's another method that is added by the Hardhat plugin. And after that, we're gonna define a nested describe block to group several tests together, and we're gonna call this deployment. And first, we need to make sure that it set the right owner, so it should set the right owner, and it take an async callback. So we are going to use the expect object here, expect method, and we're going to read the owner variable from the smart contract, and expect is going to convert the return value of the owner function to an object with some additional method. So here we can do dot to dot equal owner dot address, and so you can see that it reads very naturally. We expect the owner of this token to equal the address of the owners. Yeah, here actually when you get the signers object, you don't get address directly, but you get signer object, and if you only get the address, then this is the dot address field here. Then second test is it should assign the total supply of tokens to the owner. Okay, another async callback here. And so first we're gonna read the balance of the owner, so token dot balance of, and here owner dot address, and we're going to expect that token dot total supply, here we close the parenthesis, to equal the owner balance. And so here you can see something very interesting. So actually in this assertion and in this one, we have two different kind of comparisons. So here we compare two addresses, and here we compare two instances of big numbers. Big number is a JavaScript library which is used to wrap object that comes from the blockchain because they are too big for JavaScript. But even though we're comparing very different things, we use the same syntax, to.equal. So it's very easy to use. And it's because behind the hood, it adds some extra methods that are very useful in order to test smart contract. Next, we're going to create another describe block for another group of tests, and we're going to call this transactions. It's going to have a callback function, and inside we're going to have several individual tests. So the first one, we're going to make sure that should transfer tokens between accounts, and let's give it an async callback. So we are going to do a transfer and make sure it works. So first we call the transfer method to address one dot address, and we're going to transfer 50 token. So by default, it's going to use the first signer, which is the owner. And after, we're going to check the balance. So token balance of address one. And here we should have 50. So address one balance to equal 50. And after, we are going to do a transfer from address 1 to address 2 and make the same assertion. So how are we going to do this? So here we need to use the connect method so that token use address 1 to send a transaction. So just to be clear, in Truffle, instead of doing this, we would have done something like this, from address 1, but here we have another notation, and going to transfer to address 2 the 50 token. Then we check the balance of for address 2 and make sure it's 50. Then we are going to test a failing assertion. So should fail if sender doesn't have enough tokens. Oops. Okay, async function here. So first we're gonna get the initial balance of the owner. After, we are going to run an assertion, and so this time to test revert, we need the await keyword for expect here token. So we are going to connect to address 1 in order to send from this address. Then here dot transfer, we're going to try to transfer some token to the owner, but it's 1 token, but it's not possible because we have 0. Here you can see that instead of putting everything on the same line, I jump to a new line. So it's also possible to use this syntax if you want to separate a little bit more. And so here we are going to run an assertion like this to be, so it's not to equal, this time is to be reverted with. And in the require, in our smart contract, we put not enough tokens. So that's how we know the error message. And finally, we are going to make sure that the initial balance owner is still the same. So let's await token dot balance of owner address. And so to equal, and here should be initial owner balance. Okay, so we finished this test, and last test is we need to make sure that the balances are updated properly. So update balances after transfers. So first we get the initial balance of the owner. Oops, here actually I meant to write initial owner balance. Okay. Initial owner balance. Then we're going to transfer token to address 1 and address 2. Address 2. And then we're going to test that the final owner balance was decreased. We're going to expect this to be to equal initial owner balance minus 150. So actually, I didn't even know that we could use this syntax with a big number here, directly subtracting a big number with a JavaScript number like this. So yeah, it's an interesting finding. Then we are going to make 2 more assertions for the address 1 balance and address 2 balance. So first address 1 balance, token balance of address 1 address, and we're going to expect this to be equal to 100, and for balance 2 we're going to expect this to be 50. Okay, so our test is finished. So now we need to run it. So in another terminal at the root of your Hardhat project, you're gonna run npx hardhat test. And here we can see that all our tests are passing. Great. So if you have a failure in your test, you will see a red cross here and you will see the reason here. So now you know how to test your smart contract with Hardhat. So next, I'm going to show you how you can do some smart contract debugging in Hardhat. So let's quit this file and we're going to open our smart contract token.sol, and we're going to import Hardhat console.sol. So it basically gives you the power of JavaScript console log, but in Solidity. So here in transfer, we're gonna console log the sender balance. So for that, the syntax is first you type your text here, sender balance is, and here you're gonna have a placeholder with %s tokens, and then you pass your variables msg sender, that's gonna be the balance of the sender, and then another console log trying to send token to another placeholder, and this is gonna be amount 2. So here the first placeholder is replaced by amount, the second one replaced by 2. And so for simple type like integer or addresses, you can use this notation, but for some more advanced type like bytes, there are other forms of this console log function. So you can check out the documentation of Hardhat to see this. And so if we run our test again, it executes the transfer function. So we're going to see the console log. And here you can see the output of your console log. So this is extremely useful when you do some debugging. In this section, I'm going to show you how you can deploy your smart contract to a local blockchain and after to a public testnet or mainnet. So we're going to start with a local blockchain. So I'm going to quit my code editor and I'm going to create a new folder called scripts. And inside, I'm going to create a script called deploy.js. Okay, so let's open this. And so we are going to write our deployment code here. So we're gonna have an async function main where we're gonna write all our logic, and after we're gonna call this function main and we're gonna wait for it to finish, and if it was executed properly, then we just exit the script with 0, which means there was no problem. Otherwise, if we have an error, we console log it and we exit with 1, which means there was a problem. This is a convention of operating system. And after we go in our main function, and first we are gonna get the signer object for the deployer. So await ethers get signer. So this is like for testing file. Ethers is injected by Hardhat. We're gonna console log the deploying address. Then we're going to console log the balance of the deployer. So here balance is a big number object, so we need to turn it into a string like this. And finally, we're actually going to do the deployment. So first we get a contract factory. Then we actually do the deployment. And at the end, we console log the token address. And now we are going to run this script. So in another terminal, we are going to run npx hardhat run and then pass to our script. And then we can give a network argument, but if we don't give any, it's going to use a local blockchain of Hardhat. So this is called the Hardhat network. This is basically like Ganache CLI with Truffle. And so in this case, it's going to run an embedded instance of this local blockchain just in memory. So it deploys it, and as soon as the command finishes to run, actually the local blockchain dies. So we're not going to be able to interact with this smart contract, but doing it this way is still useful for making sure that the deployment script works fine. So let's do this. Okay, and we can see that the deployment script worked great. So next we're going to deploy to the Rinkeby public testnet. So for that, we're gonna need a URL to Rinkeby, so we can use infra for that. So if you never used it before, this is an API for Ethereum, and you can create a free account. It's gonna be enough for our need. So I'm gonna log in my account. I'm gonna create a new project. And I'm going to select Rinkeby, and I'm going to copy the endpoint for HTTPS. Then back to my terminal. Let's exit the code editor and reopen another file, the config file, hardhat.config.js. And I'm going first paste the URL for infra URL, and then I'm going to copy paste my private key. So here I am on MetaMask in my browser. I've selected the Rinkeby network, and I've already used the faucet of Rinkeby in order to send some Rinkeby ether to this address. So basically the procedure is you copy the address, you go to the Rinkeby faucet, and here you need to give the URL that point to a social network post where you have your address inside, and you click on give me ether. It's going to give you some. And so here back to MetaMask, and I'm going to export the private key. Okay, so export this back to the code. And after, we're going to define a new network. So first networks, and inside Rinkeby. So for the URL, this is going to be infra URL. And for the accounts, so this is going to be an array of all your private key. So we prefix this by 0x, and we put our private key. Okay, and after back to our console, and this time when we run the deployment script, we specified the network is Rinkeby. Okay, enter. So this time it's going to be a little bit longer. Okay, and so we have our token address, so it's been deployed. So now we can verify on the Rinkeby etherscan that it's actually deployed. So here I am at rinkeby.etherscan.io, and I can search by address. And yes, it did find my contract 39 seconds ago. Yes, contract. And yeah, here it give us the bytecode. So yes, it has worked. So now you know how to deploy a smart contract with Hardhat, not only for deployment to a local blockchain, but also for public testnet like Rinkeby, and for mainnet, this is exactly the same as for Rinkeby. In this section, I'm going to show you how you can integrate the front end of your decentralized application in a Hardhat project. So in order to integrate your front end with your smart contract, you need the ABI and the address of the smart contract. In Truffle, when you deploy your contract, it produces a JSON file called the contract artifact that contains these two information. But unfortunately for Hardhat, we are missing the address. So we need to do a bit more work. So here in the deployment file, first, I'm going to import the FS module of Node.js. So this is used to manipulate the file system, create files, save file, etc. After, we're going to create a JSON object with two fields, the address, so we can have it with token.address, and the ABI. So the ABI will need to do more work. So first, token.interface.format JSON. So this is gonna give us a JSON string but we want it in actual JavaScript JSON, so we need to use json.parse. And after, we're going to write a file with this info, so write file sync, and we're going to give it a pass to the JSON file that we're going to make available for the front end. So we're going to put it in a place where the front end is allowed to import. So let's say we create a front end in a front end directory. Then if you put all of our front end code in a src directory, and here we're going to call this token.json, and we need to give it the data to put in this file. So we're going to transform into a stringify the data object. Okay, so after, we're going to create a front-end directory, then I'm going to create a src directory. Okay, after, I'm going to start Hardhat network with the Hardhat node command. So this is basically a local blockchain. This is the equivalent of Ganache CLI if you were using Truffle, and here you can see that it generates 20 unlock accounts, and for each of them you have 10,000 ETH, and the URL is localhost 8545. Okay, so after, we are going to deploy our contract on this blockchain. So npx hardhat run script deploy, and we're going to specify the network localhost. So you don't need to define this network. By default, it's going to be localhost 8545. Okay, and so now if we check in frontend src token JSON, then we can find our two infos. So address 0x5fb something, so it matches the contract address, and after the ABI, and these two info can be consumed by the front end. So I was a little bit too lazy to build a fully functional front end, but I'm going to show you how you would do it. So here, this is the repo of either block. So you go in front end src, and here the file that set up everything is this file. So basically the idea is to build a contract pointer with the ethers library. With this object, you'll be able to interact with our token smart contract, and it needs the address and the ABI. And so here we just import token.json from the src folder, and after, in app.js, we import this pointer to our smart contract, and after, in your application, you can use this object. Also, in your MetaMask, you will have to select localhost 8545, then it will connect to Hardhat network, so the local blockchain we just started, and it will work just fine. So I show you a simple solution to export the ABI and the address with the deploy script, but if you want something a little bit more robust, you might want to have a look at this plugin of Hardhat called Hardhat Deploy. So after having tried Hardhat, how does it compare to Truffle, which is really the heavyweight for smart contract framework on Ethereum? On the pro side, with Hardhat, is very flexible. It uses TypeScript by default, and you only have to use one library to interact with Ethereum, Ethers, or Web3. In Truffle, you have to deal with an internal library called Truffle Contract plus Web3. On the con side, with Hardhat, you have to spend more time setting up your project. It's not as plug and play as Truffle. You also don't have as many integration as Truffle. And finally, Hardhat only works with Solidity 0.5.1. So if you need older version of Solidity, you need to use Truffle. So I'm curious, what do you think of Hardhat? Do you like it? Do you prefer it to Truffle, and why? Let me know in the comments down below. Bye.